Next, we have Jolanda Becker with building change detection using Siamese neural networks, which is, I confess, a sentence I do not understand. So we shall, hopefully in 5 minutes, I shall understand that.
Okay, thank you for the opportunity to present to you today. What I'm going to be presenting on is Major Look, building change detection using Siamese neural networks, and I will explain what I mean by that. So I work for the City of Cape Town as a data scientist, and I worked in the aptly named unit called data science. And what we do is we work with the different directorates of the city, like electricity and water and spatial planning. And we work with them and with their data to try and drive operational performance. And so the activity I want to talk to you about today is an activity undertaken by our evaluations department. And so let me just bring all these things up. Okay. So our evaluations department needs to timeously detect when there are changes to buildings within the city area, and they have an existing process to. Oh, sorry. They have an existing process to do this, and I'm not going to go very deep into how they are doing it because we want to actually adapt how they are doing it. So, but in short, they use LiDAR data to detect height changes, and these height changes that they detect are then reviewed by people to see if it is a real change to a building, and then that can supplement a supplementary evaluation. Yes. Okay, so what is the project for us in this? So we want to use advanced analytics, and we ended up using deep learning to be able to get the same output. So we want to harness advanced analytics to be able to do this. And so if we think of the problem in its most simplest format, we basically want to take images of properties from 2 time frames, and we want to determine if there was a change in the latter image, whether there has been a building change in the latter image. And what we want to use instead of aerial photography that is currently being used is we want to use satellite data that is frequently updated and freely available. So how will we do this? We want to harness a special type of neural network called a Siamese neural network, which can take 2 inputs. So that's where the name comes from. It has can take 2 inputs. And so, we are lucky in that we have historical data for us in order to be able to do supervised training. And the aim is for us to train a Siamese neural network that looks something like that to be able to detect building changes. And so how does this work? Is we basically send 2 images, like this example is of a person, but we'll send it 2 images of a building, and it actually goes, maybe I can point with my mouse. So the 2 images goes to the same neural network, and the neural network outputs a vector. And so you can think of this vector as of these 2 vectors as points in space. And so if the images are similar, we want the points in space to be plotted close to one another. And if the images are dissimilar or are of a change, a building change, we want the network to plot the points far away from one another. And so by doing this, based on the distance, we can actually determine whether there is the distance between these points. We can determine whether there is a change in the building. Okay, so how are we faring with this? After plugging away quite a bit at this architecture, it was quite tricky at the start, but we, in the end, managed to get an accuracy of 95%, which we are very happy with. I'll just do a quick demo. So this is the testing results from our training, after training our neural network. And so the yellow dots are, as you can see from the legend, maybe you can't see, are true positives. So I'll just zoom in on one of the properties to show you what it looks like. So if we look at the property in 2019, it might be a bit small, but hopefully you can see. That's what the property looks like, and you can see that there was a roof added over there. And so this, I just picked a random property from the map now, but this is the model actually successfully picked up that change in the building. Yeah, and so just a continuation of how are we faring. We're doing really well in terms of the accuracy on the testing data. We are running into some generalization issues if we are applying the model to a new year, but that is to be expected. I'm just going to go back to the presentation. Okay, yes. So that is basically what we did for the project. I think this project has a lot of potential. There are still some kinks we are ironing out, but it really is a promising project in terms of being able to, we foresee it being able to create value for the city of Cape Town. Thank you.
Used to hang, it doesn't hang. Thank you, Yolanda. Oh, sorry. The part that was cut off was quite clearly the of thank you. Thank you, Yolanda. That was very, very interesting.